if we draw a line, and at one end of the line we have the absolute destruction of them, and then the other end of the line we have the absolute of happy the absolute progression of them, right? Now our interface is going to do something here. I mean, I'm not sure what the probability of our interaction destroying their evolution. There's a reasonable argument that says we might actually kickstart it. We really don't know. We know microbes, bacteria, viruses are peculiar little things, right? They do weird things. They live in weird environments, and they do change. And so if we were going to try to figure out how we should interact with these, what we'd have to do is map out what the interactions would be, like actually think out what all the interactions might be, and then sample along the continuum, and then run. I mean, I could see designing an algorithm which has, maybe, I don't know, 20 or 30 entry points for different data sets, and then running multiple variations of this over and over and over again. And the Rand Corporation used to love to do this way back when, in the 60s or 70s. They would run these iterations and iterations of algorithms over and over and over again by changing just small components in the algorithms. Google does this as well, in order to try to figure out what's the optimal mix. And there's ways of doing this, but it takes a lot of work. Takes a lot of people, time, like mind time, where you're sitting down and figuring your way. A lot of whiteboards, and it's possible, but I mean, you have to come up with a way to look at it to make a better way of trying to understand things. And when you're dealing with policy, I don't know what else you could do. I mean, you could get experts in, and experts could tell you what they feel, but man, experts are so wrong. I'm writing an article called "The End of Expertise" that's going to be done by the end of September, and we did a study where we asked experts to predict what they thought the public was afraid of. We asked the public to predict what they thought the experts thought they were afraid of, and we asked the public to predict to tell us what they were afraid of, and we asked the experts to tell us what they were afraid of, and nothing matched. Right, nothing. And the scariest part of the world is it becomes more and more interdisciplinary, or choose the term, cross-disciplinary. Mm-hmm. You get this population of experts called marginal experts. They're sort of experts, but they're not experts. I mean, I studied nano for 15 years before I started talking about it, right? I mean, you've got to work at this to do it right. And what happens with the marginal experts is there's a whole bunch of research that's been connected that says those are the ones who think they're most expert when they're least expert, right? Mm-hmm. So the people who are giving all their opinions of what they think the future is going to be like and how we're going to interact with things in the future, I'm probably wrong. Probably wrong. I mean, and the fact that almost 50% of everything we've discovered about 20 to 25 years later is reversed or mitigated. That every time you try to do a study again after it's been done once, you never get the same significance level. I mean, you begin to wonder, right, that all these experts are making all these conclusions and they're wrong. So we probably need to come up with a new way of dealing with this. I mean, this is part of this NSA project I'm on. We're trying to figure out new ways of trying to get information which might be just a little bit more reliable. And so that requires a brand new way of calculating risk profiles. And that's why I think you're dealing with this microbial issue. We just don't have a risk profile for this at all. Mm-hmm. We just have nothing to compare this to. I mean, what are we going to compare it to? The introduction of smallpox in the Western United States when, in the 19th century, the white folk came over and gave smallpox to Native Americans who weren't prepared for it. Right? I can come up with hypotheticals, but there's not a lot of them, right? And again, they're all human-centric hypotheticals. And so it's a real problem.
Well, we certainly hope it's not like your example, because that would result in about 90% of our population going down the hole.
Yeah.
That would be pretty brutal. But that's also, one of the risks that, you're talking about is you're not just talking about the risk we're used to, we're talking about a risk that's so out of this world, if you'll forgive the pun, that it's difficult to even accommodate into a calculus, and that means it can be especially damaging because, you know, I mean, obviously the Native Americans were not prepared for smallpox, and that's the very death of it, you know.
I mean, there's other examples where we've done really incredibly stupid things. You know, I mean, I think I used the word proliferation when I talk. The mass proliferation of rabbit species in Australia was a good example, where we just brought in a few species thinking, hey, what the hell? And now they're everywhere, or they're just taken over entirely. The ecosystem is getting crowded out. It's trying to figure out those things, right? Which we try to do in order to come up with new. This is the methods. I mean, this is the methods and measurement issue, right? It's what method are we going to use to do this? Because the old methods for a human looking at a microbe, we spend most of our time destroying them. You know, and we'll nurture them along if it's going to benefit us in some way. But we don't really have much respect for something that's microbial.
Mm-hmm.
But I mean, we were once microbial. This is the big problem. The big problem is we're not prepared to extend this moral duty to a microbial species, even though we evolved from microbial species, which is a quandary, at least. And a sci-fi episode. It's always a possibility. You never know. You never know.
Kind of continuing on that, in terms of policy actors who kind of getting into something technical, and this might be, you know, if you feel like if you'd want to speak on this, you can. What do you think would be, you know, other than compiling this risk profile, how do you think like if you were leading the NASA expedition to Mars and this was you were in charge, you were the microbial risk guy, microbial risk consultant, how would you think that this could that even the beginnings of a risk assessment could realistically be compiled? Is this a theoretical endeavor, or is this something that we would need to be on the on the ground for? How do you think risk assessment should be or could be conducted in a policy space on this?
Well, I mean, I don't think we have to go to Mars in order to realize we're going to have a risk question. I think we can figure that out. Or we know a few things about at least the bacterial fossils that were found on Mars. That, you know, there's something that at one point was there, but we've learned a lot in I think biotechnology and genetic engineering. There's a lot of folks out there who are really primed and ready to deal with questions like this. I keep a lot of my colleagues, when we go to these big meetings talking about the morality of ethics of nano or genetically engineered machines, we get it. We get it. I mean, we know that we better come up with some better way of figuring out what it would be before we get there. It's just a hell of a challenge. That's the other problem. You've got to I hate the word co-invest. There's got to be, while we're preparing to go to Mars, we also have to be discussing the implications of going to Mars, right? I mean, they can't happen one after the other. That seems to be, we may never have the right answer, but hopefully when the expedition takes place, there'll be folks who have thought about it enough and have introduced enough of the right questions that we can ask it along the way. How best to react and how best to not act. I mean, I'm going to assume that our folks are going to be hermetically sealed in a zillion different ways. Mars is not a really nice planet. I mean, it's kind of nice looking at times, but I mean, from what I remembered out of my astronomy classes and planetary physics class, it's not the nicest place to hang. And so we'll try to isolate ourselves from the environment. And that, so we're also talking about our interaction with that environment may end up being those accidental releases, those non-intentional releases, where human microbes interact with alien microbes. And that could be real problematic. You know, I mean, without getting into a huge discussion of prions and viruses, and there's just a whole bunch of interesting ways bacteria and viruses interact with competing bacteria and viruses. You know, and I'm not sure we want to be the cause of all that.
Mm-hmm. Or want to deal with the consequences.
It'd be kind of weird to send people to Mars and realize that you can't bring them back. And I think that's something you have to think about, right? Because if there's a microbial infection that occurs and they can't really come back because we're not sure how they've been affected and the implications of them returning to their environment, that's a hell of a commitment for someone to make to engage in exploration if that's one of the price tags. You know, so it's a pretty broad issue. I mean, what I would do is like I've obviously been funded by the NSF quite a bit over the last few decades, and we talk a lot about investing in trying to understand the societal implications of what we do while we're doing it. Like let's invest in both. Let's not do stuff because we can do it. Let's let the scientists do what they're doing and simultaneously have folks who are social scientists like me and my colleagues who are following them very closely.
And have something of a division of labor.
Yeah. We dialogue a lot with a lot of folks and bring a lot of stuff to the discussion that a lot of them have never thought of before. Just kind of fun.
And I'm trying to think of, I apologize, I thought there was a question there.
You look like one of my graduate students right now. Sorry.
I feel like I was feeling more like a debater during cross-ex when they're at that 2:30 mark and they're just,
what happened? Yeah, I teach a risk communication class, and we just end up so many times at the end of this course just trying to figure out what's the right method to evaluate risk given data sets that are so incomplete, right? There's just no certainty to anything. The probabilities we're right are so low at times. I mean, you're just going, no serious statistician would take these findings, right? They just aren't significant enough. There's too many probabilities of error everywhere, but you got to come up with something, you know? And so you do all these wacky, and I mean wacky methods to generate data. And I've been involved with a lot of different studies that we had to come up with a method of generating data so we just would have it. And after it was over, I mean, we've come up with ways to fix our method, but I mean, it's just nonstop.
And when we generate data, when we kind of have the sum of the data to generate these risk profiles, do you believe that there is a moral obligation to act with significant caution when we're working with these kind of incomplete data sets? Like, does a data set need to be full and complete before we can make a call in a lot of the ways?
No, I think what we've been doing, hopefully this comes across. What we've been doing in the algorithms we've been building, for example, for genetically engineered machines, what we've been doing is looking at different sets of data that we can collect. And then for each of the sets of data, we are assigning an uncertainty value and weighing the set of data. So some sets of data weight more heavily than others because we're more certain of we're more certain of the data set. That's also calibrated depending on how important that data set is. I mean, if the data set's about extermination of all life on the planet, that's pretty damn important, right? If it's about, we might change the shades of the grass from deep green to medium green, that we're less concerned. And so it's a process of taking the data sets and moderating them by weighing them in certain ways. Mm-hmm. And you can design them and you can get provisional results when you do that. But I mean, you're right, because when you do the math out at the end, it's not multiplicative, it's like corroborative, that each of the sets might have a special relationship, so they corroborate a bit. And so you're not just getting like this is a 50% likelihood this is true, and 50% this is true, hence only a quarter, only 25% that both being true at once. There's an intimate relationship between these sets. I often tell the story about, when I'm talking to my students, about the probability of me using the F word is non-existent. The probability of me slapping my elbow on the table while I'm lecturing is non-existent. The probability of the two coming together is more significant than them happening separately. That's corroborative significance. And so when you do algorithms, what you end up setting is that these data sets aren't really independent. Mm-hmm. These data sets often bleed into each other. So if they bleed into each other and you can weight them based upon the level of uncertainty and weight them based upon how significant they might be as entire sets of data, you can put together something that will give you a value. And that value will at least be educative, right? I mean, and for policymakers, that's often all they get. You have to wonder, when Truman made a decision to bomb Japan, I mean, no one knew what was going to happen. There was all this predictions both ways, and they just had to make a decision. They had to educate themselves as best they could and made the best decision they could at the time. Mm-hmm. And I think that's what you're looking for.
That answers. That's a very good answer to the question. Just as an update, we can continue speaking, but we're reaching about an hour, so I wasn't sure if you had anything else on your plate. But I just wanted to give you notice that we were reaching about an hour.
I have nothing scheduled until about 25 minutes from now.
Okay.
It's another phone call, so